Okay, here we go. Today, we're going to talk about different types of lines and systems. So a system is two or more lines, and we like to look at their intersection. So it says three types of linear systems. The first one we classify as this. We say that you could have a linear system that looks like this. Okay. That's the most common linear system. And a system is just two or more. And when we solve a linear system, we look for the point of intersection. And at what point do those two intersect? Yeah, they intersect at 1, 2. Okay, 1, 2. So your first type of linear system looks like that, where they cross somewhere. And your second type of system would look like this, where they don't cross. Why would they not cross? What kind of lines don't cross each other? Parallel lines. Yeah, so if they're parallel, they don't cross. And in fact, if you solve them, you come up with a situation when you're trying to solve, you come up with something like 0 equals 5. Does 0 equal 5? No, it never happens. And so when you're solving a system, if you come up with something weird like that, you could say, okay, they don't cross. In this case, you come up with, like, say, x equals 1, a normal solution. And then the last type of system that you can get is if you have one line, and when you go to graph the other line, it graphs right on top of the previous line. Okay, graphs right on top of the previous line. And in that situation, you would come up with something like, say, 4 equals 4, or x equals x, or 0 equals 0. And what that means is that you have an infinite number of solutions because one line it's the same as the other. It's right on top of it, okay? And you would get that. We have three ways of solving systems. The first thing we're going to do is we're going to look at solving by graphing. And this will be a nice review for us. Okay, we actually only have 2 more lessons before we would be ready to test. My guess is that we'd be ready to test next week, Tuesday. How does that work within your schedule? Tuesday work okay? Right now I'm going to focus on Tuesday next week is going to be the goal date for us to test. So when you solve these by graphing, all you want to do is you just want to graph each one and look for where the intersection point is. Now this is nice and easy because I could graph that. All I do is I identify the slope and the y-intercept. What is the y-intercept for that first one? -2. So I plot -2. And then the slope is 1. And so I rise 1 and run 1. Rise 1 and run 1. And I get that. Now you have 2 options for the next one, and I would just like some feedback from you so I know what I know how your brain's working, I know what you're thinking. If I have x plus 2y is equal to 6, the way that I like to solve for this is instead of putting in slope-intercept form, I just like to find the x and y intercepts. So if you remember, if we plug in 0 for y, this goes away, and you end up with x is equal to 6. So that means it has an x-intercept of 6. And then you can plug in 0 for x, and you come up with 2y is 6. So what would y be in that situation? 3. And I graph the line between those two. Now, I'm just wondering, so the second one, I did not put in slope-intercept form. If people were to encounter this, would people do like I did, where you were to look at the intercepts, or would you solve for y? Which one would you do? Would most people solve for y? Okay, sounds good. We'll do that with the next one. I just wanted you to see the intercepts here. So in this situation, you want to. It doesn't look like it crosses at a really nice point. So I'm going to estimate. Okay, I'm going to estimate. I'm going to say I'm over. I'm going to say 3.2, and I'm going to say I'm up 1.5. Okay, so I'm going to estimate the point of intersection. That's one of the challenges with graphing, is it's not always real exact. Okay, it's not real exact right there. The next one, I'm going to do what you guys said, which was I'm going to turn this into slope-intercept form. And I'm going to do the bottom one by subtracting x from both sides. And I get y is equal to negative x plus 7. So I have a y-intercept of positive 7. And then I have a slope of negative 1. Down 1 over 1. Down 1 over 1. I'm going to try to get real fancy here. Then for the other one, I have 2x minus y is equal to negative 4. I'm going to subtract the 2x. Negative y is equal to negative 2x minus 4. I have to get rid of that negative, so I divide by negative 1. I get y is equal to 2x plus 4. I can plot 4. And then it looks like I rise 2 and run 1. Rise 2 and run 1. So what would you say is the solution to that system? Positive 1, positive 6. Okay. Now, most people like to be exact. Graphing is one way. Let's look at another way. By the way, this assignment, you're going to be given in time in class tomorrow to work on it. So this will be a 2-day lesson deal. Okay. Just want to make sure we get the instruction in today. So graphing is the first way. Okay, that's one way to solve. The other way is to use what we call substitution. And then the third way is to do what we call elimination. Hopefully those kind of ring a bell for you as ones you've talked about before. And what substitution means is if you know x is equal to something, or if you know y is equal to something, you can just plug it in. Okay? So Alex, would you like to use the x equals or the y equals? It's up to you. Okay, so he's going to say I've got x is equal to, so I'm going to take this thing that x is, and I'm going to drop it right there. I'm going to put it wherever I see an x on the bottom one. Now I'm just going to write the bottom equation, but instead of writing x, I'm going to write whatever this thing is right here. So I have y is equal to 5 plus 1/2 times, I type in 2y minus 10. So instead of my x, I just type 2y minus 10. That's it. And now we try to solve. So I don't have x and y, I only have y's. That's going to make it easy to solve. Y is equal to 5. I'm going to distribute my 1/2. 1/2 times 2y is just y. And then 1/2 times -10 is -5. I'm going to combine like terms. I have 5 and -5. Those make 0. So I'm left with y is equal to y. Is y always equal to y? Yeah. Yeah, if you look back here, if you end up with that kind of a solution, remember if you end up with like x or y equals a number, then it looks like that. If you end up with 0 or 1 equals 5, something that's not true, that means that there's no solution. But if you end up with something equal to itself, that means that the lines actually look like that if we were to graph them. So there's an infinite number of solutions. So we have this third type of system here. So when you don't graph them, you can still solve them, but sometimes it's harder to see what it looks like. So we would say infinite solutions. For the next one, do you have an x equals or do you have a y equals? I have a y equals. Take that. I'm going to drop it right in for y. So I have 3x minus 2 times the quantity, 3x plus 2. That equals -1. 3x, I take that -2 and I multiply it through. I get a -6x. I have a -4. That's equal to -1. What can I combine on the left side? The 3x and the -6x make -3x. I -4 is equal to -1. I add 4 to both sides. -3x is equal to 3. So x is equal to -1. A solution to a system requires you have the x value and the y value. Here I have the x value is -1. How do I find the y value? Yeah, plug it back in. If you just take that -1 and plug it in for x, 3 times -1 is -3, plus 2 is -1. So if you just plug it in, it'll tell you right what it is. Let's do our last option here. This is elimination. Okay. Elimination, and don't write this, but elimination is where you add things together and you make the x or y go away. So watch what happens if I add these. I get 5x and 8x make 13x. -4y and -4y, that makes -8y. And 0 and 12 makes 12. I didn't get the x or y to disappear, did I? Does anybody know what I can do to make sure that the x or the y disappear? Very good. This -4y, if it was a +4y, then they would cancel. So you're allowed to multiply through by a number and then add them together. So I'll write down the top one again. 5x minus 4y is equal to 0. And then the bottom one, I have a -8x, I have a +4y, and I have a -12. Remember to multiply all the way through, okay? I'm going to add those together. 5x and negative 8x make negative 3x. Negative 4y and positive 4y. Isn't that nice? And then 0 and negative 12 make negative 12. So now I have a basic equation once those x's went away, or y's went away. And so my solution is x is equal to 4. So 4 is the x value of the solution. In order to come up with the y value, you plug it back in. And it doesn't matter which one you choose. You could choose either or. Which one would you like to choose, Sin? The top one. So she's going to plug 4 in right there. And I get 5 times 4 is 20. Minus 4y equals 0. As we solve, we subtract that 20. Negative 4y equals negative 20. So y is equal to 5. And that's my solution. Last one here before you guys try a couple problems on your own or with partners, but I want you to talk with your peers and see if you come up with a strategy for this one. This was an elimination one as well, but it looks different. Talk with the person next to you. See if you can come up with something. Come up with anything. Go. Talk. Yeah. What's the big problem here? Why is this tougher than the other one? Yeah, the numbers don't match up. So you kind of just have to decide first, do you want to get rid of your x's or your y's? What would you like to get rid of, Raleigh? Raleigh wants the y's to go away. He's an x guy, right? Me too. I tend to get rid of the y's all the time. So he wants to get rid of the y's. And, we're not going to make this negative 2 into a positive 3. And we're not going to make the negative 3 into a positive 2. But what if I kind of work with both situations here and I said, you know what? I'm going to make the top one, instead of a negative 3y, I'm going to make it a negative 6y. Then I can make the bottom what? A positive 6y. If I multiply the top through by 2 and the bottom through by negative 3, then I'll have a positive 6y and a negative 6y. And then I'll be in business. The top one I've got 8x minus 6y is 22. And on the bottom I've got negative 15x plus 6y is, let's see, negative 3 times 12, negative 36. If I'm not careful, I make mistakes here. I don't want to do that. And now I just get to add them together. And notice how the 6y's just go away. And I have a negative 7x is equal to negative 14. So what is x? X is 2. Yep, I always got that awkward thing plugging. You actually have 4 equations you could use to plug it in. You could use the top one, the bottom one, or the other top one or the other bottom one. I'm just going to go straight to the top here. And I've got 8x minus 3, I'm sorry, not 8x, but just 8. 8 minus 3y is equal to 11. I subtract the 8, I get negative 3y is 3. So it looks like y is negative 1. Okay, now we're not going to solve these all through, but I want you to give a general idea of which one you would choose. If you would choose graphing, substitution, or elimination. Don't shout it out, but go ahead, talk with your peer, 20 seconds, just the first one. Graphing, substitution, or elimination. Which one did you choose? Talk, go. 5, 4, 3, 2, 1. Anybody got one they like there? Yeah. You like graphing? Okay. Anybody else? Substitution? Why did you choose substitution? Yeah, the y's already solved for it. Graphing would work. I like substitution here and just going 2x plus 4 times. This piece drops right in there. We're not going to solve it all the way through, but we are just going to find x real quick. So I have x plus 3 is equal to 24. If I distribute, I get 2x plus 4x plus 12 is equal to 24. Notice I can add the 2x and the 4x to get 6x plus 12 is 24. Subtract the 12, 6x is 12. So x is 2. And we would know what to do after that, right? Yeah. How about the next one? Talk to your peer, take 30 seconds or so. What strategy would you use to do the second one? And let's leave graphing out of it. Choose to whether or not you would do substitution or elimination. Talk. Go. Five, four, three, two, one. There's no wrong answer. What would you choose? You could choose either. I would choose elimination personally. In order to make this look better, I would choose to subtract the 2x over to the other side. And I want you to watch what happens in this situation. If we subtract the 2x, we get a negative 2x. We get a positive 3y. And that's equal to negative 4. And let's just see what would happen here. Do you want to get rid of your x's or your y's? What would you like to do? Sure. Doesn't matter which one you choose. We can go with our y's. So if I want to get rid of my y's, what should I multiply the bottom one through by? 4. And watch what happens when you multiply the bottom by 4. The top, we still have 8x. We have negative 12y. We have 48. But on the bottom, we have a negative 8x. We have a positive 12y. And we have a negative 16. What do you notice happens when we add these together? Yeah, the x's go away. And the y's go away. If the x's and the y's go away, what do you have on the left-hand side then? You have 0. Now, on the right-hand side, you have 32. What does it mean if you get 0 equals 32? No solution. If you were to graph these, they would be parallel lines. They would look like this. So there is no solution at all. And the last one, obviously, substitution or elimination. Yeah, elimination works out pretty well there. Max, you want to make your x's or y's go away? He wants to make the y's go away, so we're going to multiply this top one by negative 3. We get negative 12x minus 6y equals negative 36. And we get positive 2x plus 6y is negative 4. We add them, we get negative 10x. Max wanted the y's to go away. They do go away. I get a negative 40. So x is 4. You can plug it back in and solve for y, but that's the general idea. Okay. We won't go back and find y. I think that you guys know what you're doing there. Okay. But that's kind of the deal. We've only got about 7, 8 minutes left in class. You don't have to start the assignment. You're going to be given, so tomorrow we're going to do a couple checkpoints in class to practice some of our stuff, and you're going to be given time to work on this tomorrow in class. So feel free to set this homework aside, and we'll deal with it tomorrow and go from there. Okay? A little bit longer lesson.